Hey, I'm Vince. I work at Autodesk. Okay, so I'm going to be talking about something I wrote recently called Access. I'm still not convinced it's a useful idea, but it's kind of neat. So I do this kind of thing a little too often where I'm getting a pointer from a thing and then I have to access that and then I have to access that and I feel bad when I do it. So I usually do that, which, just make sure and in debug something will go wrong and in release something will go really wrong. So a better approach might be to start testing these things and make sure they live. And then, you do your business with thing at the bottom there. But usually I'll go a little further and I'll be like, oh, wait, I should actually have a lambda. And this one's, if you look at this, okay, so here we had the assert at the top, and now I'm just following through and doing the assert at the bottom. And this is, by the way, calling the lambda right at the end. So thing is whatever it is, a thing. And oh, hey, maybe we'll make it a std optional because that way we can test thing afterwards to see if it's cool. And okay, we have something nice now, but it's a lot less expressive than that. And so I was thinking about this for a bit, and I got what my teachers would have called distracted, but I like to call it intrigued. And I wrote something called Access. And what Access does is you pass in your object, and then some a member function, or actually member variable. And it will access that value, that member, and then if you put in another one after that, whatever you got from the first one, which in this case is a pointer, to an A, or so A pointer returns a B pointer. Then in B we return a C pointer when we call another pointer, and then in C we call thing I want, and we return that value into thing. And what Access does is, if you return a pointer, it returns a pointer. If thing I want returns a reference, it just ampersands that and turns it into a pointer. And if it's a value, it turns it into a std optional. So you can test it, and then all three of those pointers, values, pointers and std optionals have. You just do your pointer semantics on them. And in this case, if something goes wrong, we just do an assert at the end. Okay, so if we change another pointer to a bad pointer, we just fail and the assertion hits. So, yay, that's great. So this is the signature for Access. It's kind of neat. So we're using variadic pointers here, or variadic template parameters here to, you can pass in as much as you want. And the first implementation of it kind of looked a lot like this, with a whole bunch of specializations of structs, and then I sent this to a bunch of people at Autodesk, and it was like, what do you think? And they were like, what about std shared pointer? And I was like, oh right, that's a thing. So, okay, and what about unique pointer? And I was like, well, what? You shouldn't really return that, but anyways. So yeah, okay, let's specialize the struct some more. And wait, we need reference value, or reference types, so let's specialize it some more. This isn't really scaling. And so I was sad again. And then I remembered this is a thing. So type traits, use them. So what I did was I used a bunch of type trait stuff, and I created a couple. One is called isDereferenceable, which just checks if if whatever's passed into it works with a star, like star operator. And this is isMemberAccessible, which is it checks for arrow operator. I really should. I guess that's not quite the wrong name, or the right name. Maybe it should be is pointer member accessible or something like that. But anyways, did the value versions of those that we all know and love, and you wrap those together to create something called isPointerLike. So that just checks if something is dereferenceable, member accessible, and convertible to a bool, because that's one of the things we really want in the end of this. And so this code, which is ugly and messy, and okay, somebody added a custom pointer type, so we had to specialize it some more. I really don't like this, so let's change it to something like this. So now all of the logic is, it doesn't actually know anything specific about pointers, it just looks at things and says, okay, well, I'll step through this. So first we're gonna get a result, and this is like, if you call, so result is approximately equal to object first, and it's like, object might be a reference, so it might be a dot, and first might be a member, a data member instead of a function, so okay, so it might not have to be called, but anyways, let's pretend it just is that. If there's, if there are a bunch of members after, or still to be, for things still to be sent along to, we just do some recursion. Otherwise, hey, we're at the end of all of our pointers, or all of our members, and so we get the type of that was returned from that, check if it's pointer-like. If it is, we just return the value. If it is a reference, we just take the address of that, and if it's not, well, I hope it's a value. So we just return a std optional with the results stuffed into that. And it would be fun to go into the details of that, but I have 0 minutes left. So that's it. My name's Vince. This is my address. Hope you like that.